Hello everyone. Here we have got a radical equation to solve with two square root terms added on the left hand side. Let us see that how do we solve this equation. To solve this equation, the traditional way should be to square both the sides one time and we get another square root term and square again to land with a fourth order polynomial to solve. So to avoid all this trouble, we just make an algebraic identity using the terms in the square roots on the left hand side, and we denote the original equation as equation 1. So we choose the first two terms, which are x minus 1 by x and 1 minus 1 by x, and take their difference. The difference of these terms comes equal to x minus 1, and this is an algebraic identity true for every value of x. Now the left hand side of this identity can be represented as root of the first term whole square minus root of the second term whole square is equal to x minus 1. Again, the left hand side can be factored and the identity can be expressed as root x minus 1 by x plus root 1 minus 1 by x and difference of these two terms by using the difference of squares formula, which gives it as the multiplication of sum of the two terms and difference of the two terms. Now it can be noticed that the first term on the left hand side of the identity is same as the left hand side of the original equation, that is equation 1. Now we put the value of this term as x in the identity and we get another equation which is x into root of x minus 1 by x minus root of 1 minus 1 by x, and this is equal to x minus 1. This is our second equation. This equation can be further transformed by dividing both the sides by x, and the x on left hand side goes away and right hand side becomes equal to x minus 1 by x. This is further simplified and right hand side can be written as equal to 1 minus 1 by x. Now we take both this equation and the equation number 1. Addition of these two equations makes the second terms on the left hand side getting cancelled and the resultant equation becomes 2 root x minus 1 by x is equal to 1 minus 1 by x plus x. Now to get rid of the square root sign, both the sides are squared and the equivalent equation becomes 2 under root x minus 1 by x whole square is equal to the square of the right hand side term. At this juncture, we can simply square and solve whole of the equation in x, but again we will be landing with the fourth order polynomial. So to avoid that situation, even at this point, the terms in the right hand side are adjusted and the equation can be written with right hand side being equal to x minus 1 by x plus 1 whole square. X minus 1 by x is grouped together, and now squaring both the sides. On the left hand side, 2 square becomes 4 and square root sign goes off, and on the right hand side the expansion gives x minus 1 by x whole square plus 1 plus 2 into x minus 1 by x. Bringing all the terms on the left hand side and multiplying by minus 1, the equation can be written as x minus 1 by x whole square plus 1 minus 2 into x minus 1 by x is equal to 0. A simple observation of this equation indicates that the left hand side is x minus 1 by x minus 1 whole square, which is equal to 0. Taking square root of both the sides, the resulting equation becomes x minus 1 by x minus 1 is equal to 0. Multiplying both the sides of the equation by x, the equivalent equation becomes x square minus 1 minus x is equal to 0, which can be written as x square minus x minus 1 is equal to 0, which is a quadratic equation, and the quadratic formula gives the value of x as being equal to minus 1 plus minus under root minus 1 square minus 4 into 1 into minus 1, all of this divided by 2 into 1, which simplifies to the value of x to be equal to 1 plus minus root 5 by 2. So we get two values of x which are 1 plus root 5 by 2 and another is 1 minus root 5 by 2. The first value with the positive sign is positive, and while the second value with the negative sign of root 5 is negative. Now looking at the original equation, the left hand side is sum of two square roots which are supposed to be positive, and the sum of two positive values cannot be equal to a negative value, and hence The second solution with negative sign is omitted, and we have got only one solution, which is x is equal to 1 plus root 5 by 2, and it can be verified, though it is little bit interesting kind of verification, that this is the solution of the given equation. Thanks for watching.